Hi guys, welcome to our first hands-on lesson today. Today we will look at what kernel is and what is shell and make a small application. We can start from the meaning of the kernel. A kernel is the core of an operating system. It is responsible for managing all of the system's resources, such as the CPU, memory, and storage. The kernel also provides a set of system calls that allow user mode programs to interact with the hardware. It manages the following resources of the Linux system, like file management, process management, I/O management, memory management, device management, etc. And this is TM. And guys, we can continue with shell. What is shell? We can say that a shell is a program that lets you interact with your computer's operating system. It takes the commands you type in and turns them into instructions that the operating system can understand. Here is another way to say it. A shell is a program that sits between you and your computer's operating system. It translates the commands you type into something that the operating system can understand. I hope this is helpful. Also, in shell scripting, shells are usually interactive, meaning that they accept commands from users and execute them immediately. However, sometimes we need to run the same commands repeatedly, and it can be tedious to type them all in each time. Shell scripts allow us to write down a sequence of shell commands in a file and then execute them all at once. This can save us a lot of time and effort, especially if we need to run the same commands on a regular basis. Shell scripts contain a list of commands. However, shell scripts are more powerful and flexible because they can use the full range of shell features such as variables, loops, and conditional statements. To create a shell script, simply open a text editor and write down the commands that you want to execute. Then, save the file with a .h extension. For example, a shell script called myscript.h would contain the following commands. Let's continue with creating a shell script login to your Linux machine and open the terminal, navigate to the folder, where you want to store the shell script. 1. Create a new file with the .sh extension such as script.sh. With this command, touch script.sh too. Give the script executable permission by typing chmode script.sh. Three. Open the script file in a text editor and add your commands. Now, we will add some commands to the shell script. Open the shell script with any text editor of your choice and add some commands. We will use nano. Type in nanoscript.sh. Yes, we can write whatever we want here with nano command. After saving and exiting, our changes will be in our file. We open it and look and see the same change here. Now let's apply our commands here. Here we will use the echo command defined by the Linux kernel in the shell script. If we run the script here by typing the message we want, our output will appear. After completing the last changes in sh file, we come to the terminal screen and we can run our shell script as follows. Here we can see the output of our echo command. Also, we can add comments in the shell script. Any line that starts with that in the shell script is treated as a comment and is ignored by the shell during execution, except the shebang line, which we will see later in this article. Let's see an example. Yes, the only output shown here is the hello world message in the first part. The other part has not been processed as a comment. Yes, friends, we have come to the end of our first lesson. Thanks for listening. Enjoy your work. Hello friends, in today's lesson we will make a brief introduction to variables and make small applications about them. Yes, shell scripts support the use of variables, and we need not define a variable's type during its declaration. There are two types of variables. These are system-defined variables and user-defined variables. System-defined variables, also called environment variables. You can view all the current environment variables using the printnv command. User-defined variables are set by the user, and they exist only during script execution. You can define a variable by simply typing its name and assigning a value with equal sign, and access a variable by adding a $sign before the variable name. Variables are demonstrated in the following example script. Before starting our example, let's prepare our editor and terminal. There are many shells available in Linux, such as the Bourne shell, the Corn shell, and GNU Bourne again shell. You can specify which shell the script will use, even if the script is executed from another shell terminal. To do this, add these on top of the script file. This line is called the shebang line. Here we state that we will use the bash script infrastructure. Now let's define our first variable. First of all, I write a comment on the first line to indicate the location. Let's define our first variable here and give it a value as a string. We can then display it this way with the echo command. We are getting an error here, and we have a syntax error regarding the spelling of shebang. Let's fix it immediately. Let's define another variable here. By giving read-only mode to variables that we do not want to be changed later in the code, we can control the first value assigned to the variable. Here we see the mistake we made, and we see again that we cannot name the variables with the minus sign. Yes, we were able to observe the value of our variable by running our code again. And now let's test that our value here is really in read-only mode. First, let's try to assign a value to this variable again and see the error we will get when we run our script. Yes, we can observe the read-only mode, and we keep this feature in mind. Yes, now let's suppress our variable. Let's see that after assigning an integer value to a new variable, these two parts cannot be concatened or summed. We have seen that the shell script does not provide us with such a feature. Now let's move on to taking action with an input received from the user. First of all, we make a request that indicates the user's entry. Then we will assign the variable value given by the user to the variable here with the read command. Then we write our variable name to show the input we received, but do not forget to put a $sign in front of it. Now let's enter a name, and we can see that we have saved it in a variable. In this way, we are provided with a pleasant welcome in the part we have written in the code. Let's do an example here. Let's open a file according to the requested string. After receiving this name from the user, let's see a file that is automatically generated in the directory we are working in. Let's run our code, give input here, and see that our file has been created. After completing the process, we received our message and can view our file in the desktop directory. We can also view our created file in this way. Yes, friends, thank you for listening. See you in our next lesson. Hello friends, welcome again to our lesson. Today we will examine comparison operators with you. This part, which we will use later when writing our conditions, is a nice part of shell scripts. You can compare two variables in shell scripting. We make these comparisons to make decisions. We will show how to do this with small examples in this lesson. First, we prepare our environment. Let's clear the codes we wrote previously and get started. First of all, I would like to include some keywords here. These are equal to, not equal to, greater than, less than, is equal, or ASCII comparators. Let's start by trying some of the comparators here. First of all, we use them for testing. We will understand conditional statements better when we see them in future lessons. First, let's start with the equal operator. Here, we use positional arguments known as $ and question marks, which give us the output of the last line so that we can see the result after writing the expression. In this way, we will be able to see whether the outputs are correct or not. Here, 1 indicates false and 0 indicates true. Let's try to increase our examples here. Let's copy the same line and try it with a different operator. Here we will observe that the results of incorrect comparisons are 1 and the results of correct comparisons are 0. When we look at our output, we can see these in an order. Only our first and last conditions are true, the rest are false. Now let's add a line here so we can move on to new examples and not confuse the results. We can also compare strings here. Let's make an example about this. When we check this with the equal operator when two strings are equal, we observe that our output is correct, that is 0. When we check this with the not equal operator when two strings are equal, we observe that our output is wrong, that is 1. Now we can move on to string comparison as a new example. Here we see that when we compare the two strings, we get an unexpected behavior, and we cannot work directly with the equal or equal not operators. As seen in the code, we are outputting the value false, that is 1, as a result of an uncertain behavior. Thank you for listening, friends. See you in our next lesson. Hello everyone, welcome to our lesson. Today we will see conditional statements with you. Conditional statements are used to execute a block of code only when certain conditions are met. We use comparison operators to check the condition. Now we are preparing our environment. We will see some structures for these conditions. The key keywords here will be conditional options such as if and else. Let's see a few conditional statements. Now we can start our example. Let's define two variables here and assign values. In the example we will do here, let's compare two numbers as condition. First of all, we start with our if keyword and write our condition. We want to compare our two numbers with the not equal to operator and return our state as true. Thus, since our condition is verified, we will be able to perform the operation within the block. We can see our message as output in the terminal because our condition is true. Now let's check what will happen if the situation here does not occur by adding an else statement. If the condition was not met, the block in the else statements would run. Let's fix our code to see this. And we can see that our new message has been printed on the screen. We can also use conditions nested. Now let's make an example for this. Here we can define another if-else block inside the else statement as a structure. This way, when we edit our code, we will get a correct output. For example, let's compare two numbers and write a condition that is not true. Since we will enter our else block later, let's change the condition here and check whether our number is greater than 0. In this way, it will select the correct state for itself and print the message. Our new conditional statement is case structures. Direct action takes place according to the selection specified here. It has a slightly complex syntax structure. Even I can get confused sometimes, and I usually look it up on the internet. The case value that will occur according to the value of our condition here will be selected. Since we set the value here as 1, the first message will be suppressed as a condition. Let's add a new case and see what happens with a different option. Let's make an example here and ask the user to enter the condition to be selected. Here we receive an input from the user with the read keyword, and accordingly we can have the user choose the action to be performed in the case. This is important because for the first time we are making a transaction depend on the user. Yes guys, thank you for listening. See you in our next lesson. Hello guys, today we will examine loop statements with you. First, let's prepare our environment. There are total 3 looping statements that can be used in bash programming: first while statement, second for statement, and third until statement. To alter the flow of loop statements, 2 commands are used: break and continue. First, let's start with the while loop. While using a while loop here, we will go through the following structure. First of all, the expected condition is written next to the while keyword. Afterward, the desired operations are listed among the do-done keywords. Secondly, for loop. When using a for loop, the first variable is used as an iterator and takes these values throughout the loop. The operations processed during this time can also be performed during the cycle. We can continue with until statements. As seen here, its structure is very similar to the while loop, and in the same way, all operations can be performed between certain keywords. As an important note, we can say this: if the condition in the loop is met, our loop will continue. Now we can continue with our first example. I thought of a few examples for this lesson. First, we can start with the for loop. After typing the structure here, we see that our iterators will take the specified values in order. In order to see these, let's print them with the echo command in our loop. The keyword specified in the for loop is important, and we got an error because we forgot it here. We continue on our way by adding this, and as an output we see our numbers as shown in the figure. For now we will use the break keyword in our loop. If we use this keyword, loop ends. So we add a condition here and request that if this condition is met, our loop will not end. We achieve this with the break keyword. Here, when our iterator reaches the value 3, our loop ends, and thus we can only see 1 and 2 as output. If we had used the continue keyword instead of break here, our loop would only skip when it reached this step, and we would get 1, 2, 4, 5 as output. In general, when the condition is met, continue will jump to the next iterator value there, and the loop will continue by passing here as if it had never been here. Now let's come to our new cycle. Here we will see while loop. Generally, after typing the while keyword, our condition is placed. While doing this, we define an iterator and give it a value. If the condition in our while loop here is met, the loop will continue. Let's not forget to write the do and done keywords again. Here we make a mistake and forget to reduce our iterator. That's why our loop is defined as an infinite loop. We are decreasing the iterator value here, and we can see the output correctly. To test, we can increase the iterator value here and run the loop more. We can see the iterator values here as output. Now let's move on to another example. First, let's define an array here. We haven't seen it before, but let's learn here how arrays can be defined this way. We can use this array in our loop like this. Let's try to suppress our array values with echo command. We can see as output that the values here are displayed sequentially. Now let's move on to another example. Let's see what can be done using infinite loop here. Since we expect our condition within the loop to always be met, we can use true after the while keyword. When we run our code here, we will get continuous output and it will be very fast. So we can use the delays that our operating system provides us. With the command we will use here, we will repeat our operations at 1 second intervals, and we will be able to observe our output better. Yes, our cycle can continue like this forever, but we stop it. Now let's move on to another example. In our example here, we will end our process with a request from the user. For this, we will check a value assigned to our variable by the user and end our loop accordingly. Here we ask the user to enter a number, and if the number is correct, we want the loop to continue. Otherwise, the loop will end and the program will be terminated. Here we set our choice value to yes in order to enter the first condition of our loop. And if the user receives a value other than yes, we end our loop. Yes, friends, we have come to the end of our lesson. Thank you for listening. See you in the next videos. Hello everyone, welcome to our lesson. Today in our lesson we will see positional arguments. First, let's get our environment ready. Positional arguments or special parameters are the arguments or values which we pass to the shell script while executing the script. In this lesson, we will discuss the special parameters of the shell script. Before we do that, let's understand what parameters are in the shell. Don't forget, guys, a parameter is an entity that stores a value. The variables are parameters that are defined by the user to use in a specific shell script. Special parameters are read-only variables that are predefined and maintained by the shell. For now, we can see these parameters in example. In our first example, we can see that the script name can be obtained as output with the specified argument, as seen in the figure. We can also print it as output with the $ and 1 as the first argument after the script name. In our example, we can give the arguments after our script name one by one. Likewise, we can access our second parameter by giving the argument number we want after the $sign. Thus, in the arguments we give, we use the hash sign after the dollar sign. Since we have two arguments here, we will see two outputs. In another example, we can obtain the output of all given parameters in a single way. We have also come to the part that I use the most. Here we can suppress the status of the previously executed command. If the last command is executed correctly, it will return 0. There is also a place here for the PID section, which will be included in our advanced topics later. Sometimes we will need to kill the process if we want, but first we will need to learn the PID. This is how we can learn the PID of the shell we are running here. Yes, another thing we need to learn is the flags of our shell. We can print these on our screen along with the dollar and minus signs. HB flag is used to print the help message for the command being executed in a byte-like format. Yes guys, thank you for listening. See you in our next lesson. Hello friends, today in our lesson we will see how to store the outputs of commands. Here we can see the directory we are currently working in with the pwd command. When we put the command here into a variable, let's suppress it with echo command. We will see that we get the same result. Here we can store any command this way. Let's do another example. We can obtain information about the status of the objects in our directory. With the ls-la command, we can assign them to a variable in the same way and see the output. Let's do an example here. Let's check whether the directory we are working with is the directory we want with the pwd command. Here we will use our else statement along with our if statement. If our directory is as we want, let's see the correct directory message. If not, let's print it with a different message. As you can see, we get this output when our directory is correct. However, when we try to access our script from a different location, the directory we are in is not correct and we see the message in the else statement. Yes guys, thank you for listening. See you. Hello friends, today in our lesson we will see the exit codes of shell commands. Whenever a command ends and returns the control to the parent process, It returns exit codes between 0 and 255. Exit code 0 means the command was successful, and any other exit code means the command was unsuccessful. You can view the exit code after running any command by accessing the $in variables. You can manually set an exit code for your shell script. This can be used with conditional statements to convey if the script's purpose was achieved or not. Now we will make a small example about this. We will ask the user for a number. In return, we will tell it to return an exit value. After completing our code here, we receive an error due to our syntax error. Let's fix that right now. Later, when we give the value 100 as input, our first if statement is executed and we see the message like this. When we give a value other than 100, our else statement is executed. We can see what kind of value our script returns to us with the positional arguments we have seen before. Here, after our script ends, we can see the output values as $ and question mark. Here, when we enter the value 100, we can see that our output is 0. We have seen this with positional arguments. Yes, friends, thank you for listening. See you in our next lesson. Hello everyone. Today in our lesson we will make an introduction to the subject of redirection. First, we can prepare our environments. The topics we will see here will be override redirection and append redirection. We can briefly talk about redirections as follows. When you run a command in Linux, it can take input, produce output, or both. Redirection allows you to change the default destination of input and output. This can be useful for a variety of tasks, such as saving the output of a command to a file, or providing input to a command from a file. For example, when we run the date command, it gives us output to the screen. However, if we want to save the result to a file, we can use output redirection. Here we will send the output of our command to a different place, and this way we can store the output of the date command in a file and reference it later. These directions can be useful when we work with multiple and large outputs or inputs, since we can use file data directly as input and store the results in files. Yes, friends, here we can also save the output we want to a different file using overwrite redirection along with the echo command. This way, when we refresh our file, we see the change. If we want to see it separately as output, we can add it to our script with the cat command. What we also need to see here is the append redirection. If we add this, the new output we will add will be appended to the old file. In this way, we can see that the text file grows as our script runs. Now, let's see how to use input redirection. Input redirection in shell script is a way to redirect the input to a command from a file or another input source. This can be useful for a variety of tasks. such as processing large amounts of data or automating tasks. The redirection operator tells the shell to read the input to the command from the file or input source that follows it. For example, the following command redirects the input to the sort command from our file. Here we save some words to our text file. Then we will wait for it to be processed as input and sorted with the sort command. Yes, we can see that the input we gave with redirection entered the process correctly. Yes, friends, we have come to the end of our lesson. Thank you for listening. Hello everyone, welcome to our lesson. Today we will continue with our second lesson, which is the continuation of redirection. Here we will specifically focus on merged redirection and give examples of them. Merge redirection in shell script allows you to redirect the output of a command or a program to a specific file descriptor instead of standard output. The syntax for using merge redirection is the greater than and ampersand an operator followed by the file descriptor number. For example, the following command redirects the output of the ls command to the file test.txt while also merging the output. In this example, the greater than ampersand and one operator tells the shell to redirect the output of file descriptor 2 standard error to file descriptor 1 standard output. This means that any error messages output by the alias command will also be appended to the file test.txt. Merge redirection can be useful for a variety of purposes. For example, you could use it to log both the standard output and standard error of a command to a single file. You could also use it to combine the output of multiple commands into a single file. Okay guys, we can continue with error redirection. Error redirection is transferring the errors generated by some false commands to a file rather than sdout. Whenever a program is executed at the terminal, 3 files are generated: standard input as 0, standard output as 1, and standard error as 2. These files are always created whenever a program is run. By default, an error stream is displayed on the screen. In the below mentioned example, the file descriptor used above is 2 as stderr. Using 2 and greater than redirects the error output to a file named error.txt, and nothing is displayed on stdout. Yes friends, here we can only see our stderr message in the file along with the redirect. Here, 2 greater than ampersand 1 means that stderr redirects to the target of stdout. More formally, the error message generated by 2 gets merged with the current output, 1. Also guys, we need to add this note. Greater than and ampersand operators can be used to redirect both standard output and standard error, but it is not supported in all shells. Esh and ksh do not support, and while bash and zsh support it. Guys, our new TOEIC is discarding the output. Sometimes you will need to execute a command, but you don't want the output displayed on the screen. In such cases, you can discard the output by redirecting it to the file dev null. To discard both output of a command and its error output, use standard redirection to redirect stderr to stdout. Here 2 represents stderr and 1 represents stdout. You can display a message onto stderr by redirecting stout into sdir as follows here. Thank you for listening to our lesson, friends. See you in the next lessons. Hello friends, today we will talk about a new concept with you. Our topic is here document. A here document in shell programming is a special block of code that is passed to a command as standard input. It is often used to pass multi-line strings to commands, including shell scripts, which can then process them as a single string. Here, documents are introduced by the less than operator, followed by a delimiter token. The delimiter token is a word or phrase that is used to mark the end of the here document. The data for the here document is then provided on the following lines, and the here document is terminated by the same delimiter token on a line by itself. First of all, we prepare our working environment and prepare for our code. For example, the following command uses a here document to pass a multi-line string to the cat command. Yes, here we put the less than sign after the cat command and follow it by typing EOF to indicate where our commands will end. Here we can branch into different strings instead of EOF. For example, we can write a command or a different string. But make sure that the two here words are the same. Yes, we can also put different strings instead of AOF. Here we can write command or any other string. The only important rule is that the text here should be the same. Now, another example is the WC command. With the Sed command, we will receive information on how many lanes there are in total. I am writing a messages line by line here, and we will see the number of the lines and of this script. We see here, since there are 1, 2, 3, 4, 5, 6, 7 lines, the answer will return us as 7, but we got the output as 9. Yes, friends, we made a mistake here and made the empty lines count. Therefore, when we delete the empty lines and run it again, we can get the output 7. Yes, we found our output correctly. The total number of rows we will get here is 7, and we see another example is the sort command. Here we can specify the words as we wish. I can write last here or anything, but it has to be the same as my last token word. We can list the words we will write here. I enter multiple words one by one and see them sorted as output. This ordering is of course alphabetical. Friends, we can see in the output that the strings we gave are listed alphabetically. And another application is that we can give the commands sequentially here. Here we will enter different commands in a certain order. Yes, here we can set our token again to the word we want. This appears to be a good option for us in every example, but I will still use EOF here to indicate it in general. First of all, we will pause our process for 1 second with the sleep command. We indicate these commands that will come later at 1 second intervals here. And as we see, we obtain the outputs respectively. Now let's try to write the texts we specified in a file here with a new example. Here, thanks to the EOF keyword, all written text will be saved in our text file until we see the next EOF keyword. Now let's look at the output of this. Yes, friends, as you can see, our text is saved in our file. Thank you for listening to us. See you in our next lessons. Hello friends, today we will move on to a new topic with you. Today we will examine what piping is. Before we start our operations, let's prepare our environments. Firstly, we can start with pipe means. Pipe is a form of redirection. Pipe transfers standard output to some other destination, and that is used in Linux and other Unix-like operating systems to send the output of one command, program, or process to another. We can make it do so by using the pipe character. The pipe is used to combine two or more commands, and in this the output of one command acts as input to another command, and this command's output may act as input to the next command, and so on. The command line programs that do the further processing are referred to as filters. For example, the following command uses a pipe to connect the output of the ls command. This command will list all of the files and directories in the current directory, one screen at a time. The ls command produces output on standard output. Piping can be used to connect any two commands that produce and consume text data. This makes it a very powerful tool for shell scripting. Yes, we can see the old text files in this directory. Also, we can continue with chain commands. Chain commands are to use piping to chain multiple commands together. For example, the following command uses piping to chain together the ls, sort, and unique commands. This command will list all of the files and directories in the current directory, sorted by size in reverse order, with duplicates removed. Yes guys, for now we can continue with process input from a file. Here, you can use piping to process input from a file. For example, the following command uses piping to process the input file a.txt and print the output to the console. This command will sort the contents of the file a.txt in reverse order and print the output to the console. Yes guys, the other new topic is how can I redirect the output of a piped command to file. We can use redirection operator to redirect the output of a piped command First, we list the files here, and with the piping process, we obtain all txt files here. Then we transfer all the information we obtained to a file with the redirection operator. Yes, friends, when we look at our file content, we can see that we have recorded this information correctly. To sum up, guys, piping is a very powerful tool for shell scripting. It allows you to connect commands together to create complex data processing pipelines. Thanks for listening, guys. See you in our next lessons. Hello everyone, today we are moving on to a new topic with you. Our topic is to pass and parse Linux shell script arguments and parameters. First of all, let's prepare the environment in which we will work. Yes guys, there are two ways to pass arguments and parameters to a bash script. Firstly, positional arguments. These are arguments that are passed to the script when it is executed. They are accessed using the $1, $2, etc. variables. Secondly, named arguments. These are arguments that are passed to the script using the minus or minus minus prefix. They are accessed using the opt-rg variable. To parse arguments and the parameters in a bash script, you can use the getops command. This command allows you to define a set of valid arguments and options, and then parse the command line arguments to see which ones were specified. Here is an example of a bash script that uses getops to parse arguments and parameters. First, we select the specified opt-args that our system can define. We will then follow this in a specific order within the cycle. We will constantly check these as cases and choose these parameters and make decisions. If the argument is selected as minus, here we'll go into the first case here. This way, the logic will continue. Yes, friends, we have finished our first part. The next step we will do includes positional arguments. First, we check that the number of parameters entered is greater than 0. If this condition is met, we continue with a for loop here to show the positional arguments. Now we can run and test our script. We have a syntax error here. First we run it and try again. And as our result shows, the arguments are correctly specified. Yes guys, for now we can start with a new topic shift keyword. You can also use the shift command to iterate over the positional arguments. The shift command removes the first positional argument from the list of positional arguments. Here is an example of a bash script that uses the shift command to iterate over the positional arguments. In this example, as long as there is the number of arguments, we will see the arguments as output. That's why we use a while loop. And since the first arguments are constantly removed, we print the remaining first argument to the screen. This cycle continues until we have no variables left. Now we have completed our example, friends. Let's test my code by giving different arguments here. As we can see, the arguments here are displayed respectively. Thanks for listening. See you in our Hello everyone. Today we continue with a new concept. Our new concept to perform operations on a file on shell script. Shell scripts can be used to perform a variety of operations on files such as reading, writing, appending, deleting, moving, renaming, and changing permissions. Here are some examples of shell scripts to perform operations on files. First, we start with reading. Normally we could see the content with the cat command. What we want to do here is to run the cat command via a variable. In this way, the file to be read can be seen in a variable. Yes, as we see, we saved the content here with a variable. Secondly, what we want to do is add something to a file. After adding to our file here, we can see it from the terminal with cat command. And the command worked and the correct output appeared. In our next file operation, we want to add more text to our file. After doing this, the words will be appended. Yes friends, as you can see here, we have a text that combines with the previous text. Append processing occurred correctly. Our next step here is the move operation. We can move our file directly to the directory we want. I choose temp directory here. And we can do this by opening a new terminal and using the ls command to check whether our file has been moved or not. Yes friends, we see our file. I run the command here in the same way to restore our file to its previous location. Now our other topic is naming our file. Likewise, we can do this with mv command. When we give the new name of our file as the second argument, the operation will occur correctly. Here we can check the content of our file again. Yes, our other topic is change permission. Here we can look at the previous permission with ls-la command. Afterwards, we can change our permission and compare it. "777" permission means granting all permissions, and when we checked again, the permissions were changed successfully. Another topic is deleting our file. Here we can remove our file with rm command. As you can see, we can delete our files when we give the files we want to delete as the first argument. Now we can move on to our new topic. Here we will check whether our file exists. First of all, we learn the file name of which file the user wants to check. Afterwards, we can check this file name with the -e option in the if condition. If we have a file, the message looks like this. However, if we search for a file that does not exist, we can see the message that our file cannot be found, as shown in the figure. In our current example, let's check whether our file size is larger than 0 bytes. Likewise, we take the name of our file as input and test our operation in the if condition with the -s option. If we run for an existing file here, we can get the message that our size is greater than 0. Otherwise, the state in our else condition will be realized. Another example is reading our file line by line. Here, first of all, we get our file name in the same way. When we use the red command with the -p option, we can also add our message here. Then we can read the lines of our file one by one in an endless loop and print them on the screen. Now, in our new example, we will print the number of characters, number of words, and number of lines in our file. Likewise, let's request the name of our file. Then let's put our different commands into different variables. The commands in the variable here will give the number of characters, number of words, and number of lines respectively. Then let's put the information here on the screen. I realize I made a mistake here because I saved my commands as string. When I check my output after fixing this, I can see the values belonging to the file here. Thank you for listening, friends. See you in our next lesson. I wish everyone Hello everyone. Today we will give a general summary of how to use the grep command. The grep command is a powerful tool for searching and filtering text in shell scripts. It can be used to search for patterns in text files, find specific lines of text, and extract data from text files. Here is an example of a shell script that uses the grep command to search for log files for specific errors. Search for log files that contain the error message system. Search for log files that contain the error message system and ignore the case grep -i system var log syslog 1. Search for log files that contain the error message system and print the line number of each matching line grep -n system var log syslog 1. Here are some examples of how to use the grep command in a shell script. Search for all lines in the file myfile xt that contain the word hello. Search for all lines in the file myfile.txt that contain the word hello and world here. Search for all lines in the file myfile.txt that do not contain the word hello with -v command. If you want to print the line number of each line in the file that contains the word hello, you can use this command with -n command. Yes guys, we can see the result in our terminal, and also we can save this output, a file n of our operation. Also, here we will use some other options with grep commands. 1. Case insensitive search. The I option enables to search for a string case insensitively in the given file. It matches the words like hello with uppercase O. The other example is displaying the count of the number of matches. We can find the number of lines that match the given string or pattern with -C command. Our third option is to display the file names that matches the pattern. We can just display the files that contain the given string or pattern with -L command. Fourth option is checking for the whole words in a file. By default, grep matches the given string pattern, even if it is found as a substring in a file. The W option to grep makes it match only the whole words with -W command. The fifth option is displaying only the matched pattern. By default, grep displays the entire line that has the matched string. We can make the grep display only the matched string by using the -O option. Another option is to use -V option for inverting the pattern match. You can display the lines that are not matched with the specified search string pattern using this option. Here, when we search for a nonsense word with the -V option, we can see the entire text as everything except this word will be seen. To make sure of this, we can observe the text with the cat command and see that it is the same. The other property is matching the lines that start with a string. The fun regular expression pattern specifies the start of a line. This can be used in grep to match the lines that start with the given string or pattern. The 10th operation also specifies an expression with the -A option. Can used multiple times like this. The most important property is to print n specific lines from a file. -A prints the search line and n lines after the result. The last property is to search recursively for a pattern in the directory. -R prints the search pattern in the given directory, recursively in all the files. The syntax is like that. In here, -I to search for a string case insensitively, and -R to recursively check all the files in the directory. To sum up, the grep command is a powerful tool that can be used to perform a variety of tasks. Hello everyone, today we continue with our new concept. Today we will continue with the subject of aliases that will facilitate our transactions. Aliases in shell scripts can be used to create shortcuts for commonly used commands. To create an alias, you use the alias keyword followed by the name of the alias and the command that you want to alias. For example, the following alias creates an alias called L. For the ls -ll command, but only we need to use the shop operation. The shop -s expand aliases command is used to enable the expansion of aliases in shell scripts. By default, aliases are not expanded in shell scripts. This means that if you use an alias in a shell script, the shell will interpret the alias as a literal command. To enable the expansion of aliases in shell scripts, you can use the shop -s expand aliases command at the beginning of your shell script. For example, the following shell script will enable the expansion of aliases. If you run this shell script, the else -l command will be executed. As seen here, we can briefly use this command in more than one way, and the results we get are as seen. Let's separate the outputs here with an echo command and observe them again like this. There are a few reasons why you might want to enable the expansion of aliases in shell scripts. It can make your shell scripts more readable and maintainable. For example, you can use aliases to create shortcuts for commonly used commands. It can simplify complex commands. For example, you can use aliases to combine multiple commands into a single command. It can allow you to use aliases in shell functions. Here are some additional tips for using the shop -s expand the aliases command in shell scripts. Place the shop -s expand aliases command at the beginning of your shell script. This will ensure that aliases are expanded in all of the commands in your shell script. Be careful when using aliases in shell scripts. If you are not sure what an alias does, you can use the alias command to view the definition of the alias. Test your shell scripts thoroughly before using them in production. This will help to ensure that your shell scripts work as expected. To sum up, guys, aliases can be a powerful tool for making your shell scripts more readable, maintainable, and efficient. By using aliases, you can create shortcuts for commonly used commands and simplify complex commands. Here are some additional tips for using aliases in shell scripts. Use descriptive names for your aliases. This will make your shell scripts easier to read and understand. Use comments to document your aliases. This will help you and others to understand what your aliases are doing. Test your aliases thoroughly before using them in production. This will help to ensure that your aliases work as expected. I hope this information is helpful. Please let me know if you have any other questions. I hope this information is helpful. And thanks for listening, guys. See you in our next lessons. Hello everyone, today we will examine the wait command, which is an important specifier. Wait command is one of the process management commands. The following shell script demonstrates the use of the wait command in Linux. First, we will create a few background processes here. The sleep command is suitable for this, and we can run it in the background with the ampersand sign. As you can see, our output may appear after waiting for 2 seconds, but we need to use the wait command for this. Even with the wait command, processes are waited and we can see the finished text. This script demonstrates how to use the wait command to ensure that all background processes have finished before exiting the script. This is important because it prevents the script from exiting prematurely, which could leave unfinished tasks behind. Here is another example of a shell script that uses the wait command. First, create a simple process that will create the file and write into it, and this will store the process ID of the running process $, and the exclamation mark is a special variable in shell scripts that will hold the PID of the last active process Salman and wait until the process is completed with wait command. As you can see here, the PID of our running thread is visible. Then we can see our output with our end message. Yes, friends, we have completed our lesson. See you in the next lessons. Hello everyone. In today's lesson we will summarize the signal handling mechanism and realize our examples. Signals are a way for the operating system to notify processes of events such as a keyboard interrupt SIGINT or a termination request SIGTERM. Signals can be used to implement a variety of features in shell scripts such as graceful shutdown or handling user input. To handle signals in a shell script, you can use the trap command. The trap command takes two arguments, the signal to handle and the command to execute when the signal is received. The following example shows how to use the trap command to handle the SIGINT signal. As seen here, we write in our Grep command how it will react when our SIGINT signal arrives. We will do this in an infinite loop and make an observation at 1 second intervals. Yes, guys, after the CTRL-C process, only we are seeing that this program is not terminated. Therefore, we need to develop our code as shown, guys. Yes, friends, Ilan, we will try to handle this situation by adding a new function here. Here we add a condition for our script to stop after the signal arrives and write it like this. We need to specify it in the command trap we wrote here so that we can see how it will react when the signal arrives. And we see that our application terminates after our CTRL-C command. Yes, guys, our new topic is chaining the signal handlers. We can combine our commands after the CTRL-C process. We used the SIGINT signal as an example to learn the trap command. First, we demonstrated the custom CTRL-C handler. Here we will write our functions one after another in the trap command. So we create two similar functions, then we specify them in the trap command and tell them in what order they should run after our signal. We write our infinite loop again and observe what kind of output we will get after receiving our interrupt. As seen here, our functions worked consecutively after the CTRL-C command. Yes, friends, we have completed our lesson. See you in the next lessons. Hello friends, in today's lesson we will see how we include the debugging option in our system and what kind of output we get. Debugging in shell script is the process of identifying and fixing errors in a shell script. There are a number of different ways to debug a shell script, including using the set-x option. This option will print a trace of every command that is executed, along with the arguments to the command and the value of any variables that are expanded. This can be helpful for identifying errors in the flow of the script or in the syntax of individual commands. Using echo statements. You can insert echo statements at various points in your script to print the value of variables or the output of commands. This can be helpful for tracking down errors or for understanding how the script is working. In addition to these general debugging techniques, there are a number of specific things you can do to make your shell scripts more debuggable, such as use descriptive variable names and function names. This will make it easier to follow the flow of your script and to identify errors. Break down your script into smaller, more manageable functions. This will make it easier to debug individual parts of the script. Use comments to explain what your code is doing. This will make it easier to understand your script and to identify errors. Test your script thoroughly with different input data, and this will help you to identify errors that may not be apparent when you are running the script with a small set of test data. Here is an example of how to use the set-x option to debug a shell script. Here we write our function that we can debug and give the text we want to see as an argument. Afterward, we can disable the debugging option again as follows. We do this with the set+x command. Now, when we see our outputs, we can see them together with the commands called when our debugging option is on. In summary, debugging shell scripts can be challenging, but it is an important skill for any shell scripter. By following the tips above, you can make your scripts more debuggable and identify and fix errors more quickly. Thank you guys for listening. See you in our next lessons. Hello everyone, in today's lesson we will explain what regex is. We can also see its expansion as regular expressions. So what are these? Regular expressions are a powerful tool for text manipulation and pattern matching. They are used in a wide variety of applications, including text processing, data validation, and network security. Shell provides several built-in features for working with regular expressions. These features can be used to search for, replace, and extract text patterns from strings. First, let's prepare the text file we will use and our working environment. First, let's save the output of the file we will read with our cat command in a variable. Let's see what happens later when we want to print this output on the screen. Here we could not get the output correctly because the event we wanted regarding the spelling did not work. Therefore, let's try to obtain the output of this command with a different spelling rule. As you can see, we were able to save the contents of our file into a variable. Now we can move on to the example we will make with Regex expressions. Here we need to add a few more lines to use in our examples. We will see its benefits in the examples we will use. In our first example, we will use the dot sign. Using dot sign, we can find a string if we don't know the string exactly, or just remember the beginning and end of the string. We can use dot sign as the missing character, and it will fill in that missing character. Secondly, using the caret sign, we can find all the strings that start with the given character. Here we will want to see all the words that start with I, and the outputs in the last 3 lines we wrote will match it, as seen in the outputs. In our next example, using $sign to match the ending of the string, we can find all the strings that end with the given character. Here we can see all the lines ending with A. We notice that the line below ends with a space character, not A, so if we fix this, we can see our message correctly. Let's write another message and see if we can view it too. And as can be seen, we could see our 2 lines in the same way. Now the example is using asterisk sign to find any number of repetitions of a string. Using asterisk, we can match up to 0 or more occurrences of the character of the string. In the example we have done here, we ensure that the words we want are like this by specifying apple with an asterisk. When we write another word here in the same way, we get a similar output. We have gone through a few simple examples here, but there are advanced sections for Regex. This way we made a good start. See you in our next lessons. Hello everyone. In today's lesson we will make an introduction to the use of Sed Command and explain how to use this command in a simple way. The Sed Command is a stream editor that allows you to perform various operations on text files. It is commonly used for tasks such as searching or replacing, inserting, and deleting text. You can use the sed command in a shell script by embedding it within the script. Here's an example of how to use the sed command to replace all occurrences of the word. The 2 words we write after the letter S in quotation marks after the sed command are important. In our example here, we will change the words heli to high. Later we can see these as output, but we cannot make any changes to avoid corrupting our file. So we do not save these files. Our next example is to delete all lines containing the specified word. Here, after this sed command, we write the word we want to delete and indicate it with the letter D. As seen here, all lines containing the word hello written in this way . Our third example is to insert a word. Here, we write the number of lines and the word we want to insert after the cd command. As seen when we run this word is added to the first line. If we wanted to put the word abi on the third line instead, we would write it as 3i. And as we see, the word appears in line 3. In our last example, we have to append the word. What we will do here after the sed command is to use the letter A. When we look at the output, we can see that our word has been added for each line. Thank you for listening, friends. Sed command is a long topic and has different features. We can conduct more detailed research as needed. Good day to everyone. Hi everyone. In today's lesson, we will try to obtain some data about the user with the input provided by the user. This will be a small video as an example. Now let's move on to the subject of our lesson. Every operating system allows for the creation of multiple user accounts. Linux-based operating systems offer various commands and functions for managing user accounts and their details. In this lesson, we will delve into these methods and demonstrate how to create a shell script to efficiently accomplish these tasks. Here in our script, we will write our code and use switch cases to compare the user input. We have used some useful commands which will help us to satisfy the user requirements. Let's begin the script. Let's first print our messages to inform the user. Here, we can print the information repeatedly after giving the -e argument with the echo command. Thanks to the messages we make here, we will offer options to the user. The user will be able to make transactions with numbers such as 1, 2, and 3 that he chooses from here. Now, let's first see the output of our echo command, and we can observe it correctly. The next step is to ask the user to make their selection by taking an input. Here we will produce output according to the input given by the user with the case structure. If our user selects 1, information will be displayed on how many users have logged in total. If our user selects 2, the last logged in users will appear here. If our user chooses the third option, we will obtain the group information of the current user. Finally, let's print a different message here in case he makes the wrong choice. Now we can test our code. When we press 1 here, we get the value 1 since we have only one user number. By selecting 2, we can see our username. And by selecting 3, we obtained the group's information. But if we made a different choice, we only saw the message at the end. Hence, we were able to find out various login related results using our shell script. Thanks for listening, guys. See you on our next examples. Hello everyone. In today's example, we will write a script that will delete files that have been created in our system for nothing and take up 0 bytes of space that have never been used. A 0-sized file is a file that contains no data and has a length of 0. It is also called a 0-byte file. Incomplete transfers can be responsible for the 0-sized file. For now, we can create a 0-sized file intentionally by running the touch command in the terminal. Here we can look at the sizes of the files in our directory with the ls command. Here, let's create our files with touch, and we can see that their size is 0. Yes guys, we can continue with our script. First, our perspective is to check if the directory exists in the current folder directory, and use for loop to traverse each file and check its size. The if line checks if the directory exists. If it does, the following code block is executed. The echo directory exists line prints a message to the user that the directory exists. The for loop line iterates over all zero-sized files in the directory. The rm command line removes the current file. The last line, done line, ends the loop. The else line is executed if the directory does not exist also. Now we can look at our output. Here, let's first give a ridiculous directory as a directory and make sure that the else statement works. Now we can test our own directory and delete the places with 0 file size. As you can see here, we made a mistake. Now let's examine our mistake. Generally, while debugging, let's observe where the error is with the echo command. As you can see, we cannot find the necessary files. Let's change the place info here and continue on our way. We can test the command here this way and see that we can access our zero-size files. Now we can change the location we changed with echo with rm command. And as you can see, our files have been deleted from the desktop. Thank you for listening, friends. See you in our next lessons. Hi guys, in this lesson we will discuss the process in shell script. Processes are a fundamental part of shell scripting, as they allow you to automate tasks and control the execution of programs. In this guide, we'll explore how to manage processes in shell scripts using various commands and techniques. You can leverage shell scripting to automate process management tasks. We can continue our example here. This code defines a function called infinite loop that prints hello world to the console every second forever. The function is then called in the background and its process ID. For now, we can write our script. The while loop starts an infinite loop here. The echo hello world line prints our message to the console. The sleep one line sleeps for 1 second. The done line ends the infinite loop. For now, we completed our infinite function. Now let's call our function here and see that we get a continuous output. If we start this with the ampersand operator, we create a background process and it appears on the console like this. To stop this, we need to list all processes with the PS command. Reach the PID of our function here and then terminate it. Now let's write this process into script. Here, we first need to record the PID of the background process we started. In our example here, let our background process terminate after 6 seconds. And let's print its PID to the screen so that we can observe the result. Yes, friends, as you can see, our transaction has been completed. In addition to these, as we have seen, there are several tools to view processes. The PS command provides detailed information about running processes, including their PIDs, user IDs, CPU usage, and start times. And our other important tool is Top Command, and the Top Command displays real-time CPU and memory usage by processes, allowing for identifying resource-intensive ones. Thanks for listening, friends. See you in our next examples. Hello friends, today we will learn to interpret the output of a command, and we will do this with Grep Command. The exit status of a command is a number that indicates whether the command was successful or not. A 0 exit status indicates that the command was successful, while a non-zero exit status indicates that the command failed. First of all, we will write a script here and we will get random outputs. This will be our real-life test case. We will capture the random outputs produced in the function here with the grep command and continue or kill the process. There are many ways to implement probabilistic functions in shell scripts. One common approach is to use the random command to generate a random number and then use that number to make a decision. For example, the following code defines a function that creates two random output, false XSX or true XSX. What we are trying to do here is to decide whether to continue our operations here by interpreting the message in the previous process. Yes guys, now we